I put a couple of screws in here. They're short. Um, I like to widen the port out to the screw heads, and it ain't very much on these, but I'll take whatever I can get. And then I generally lower the floor, um, not at the port window, but at the flange here. And I blend it in. I want to try to get a little more downward flow, and I want this port to open up as it's coming out for the expansion of the gases that's coming out of there. Um, it generally makes a big difference on these, so that's what I'm going to do. something like that. I'll probably do the transfers next. I'm practically set up to do that anyway, so get set up for that. We'll move on. I was gonna work on transfers next, but I haven't cut the squish band yet. Kind of need to do that. So I need to reset my cutter. Alright, looking good. We'll get over to the vise and start cutting. We got a long ways to go. We got 33 degrees of interference. So I cut 40 off the base and I know it was hitting there. And a gasket delete. So we got nearly 60 thousandths to take out of that squish band. So it'd be somewhere close in there. So it's going to take a bit of twisting and turning to get all that out of there. I cut the squish off camera. Squish relief is in there. Set my block for my transfer height. And a little more blowdown than I want, but it is what it is. Exhaust is higher than I want it. I set the transfers where I want them, and we'll live with the blowdown and high exhaust. It's fine. It's much better than what it was, and I have to work with what I have. So it is what it is. I can't go any further. I'm cutting the base in the squish, or my compression is going to be crazy, and I start getting into the point to where, you know, I'm going to start hitting the spark plug with the pistons. So that's what we live with, and so I'm going to move on, do the transfers, and then the intake port, finish up the intake port, and we'll be done with the cylinder, and we'll move on to the rest of it. Still got to do muffler and all that kind of stuff. So on with the transfers. I don't know if you can see in there, but probably not. Did I get a light? Let me get a light. I'm going to light her on a little bit. Maybe we'll get rid of some glare here and there. And you should get a peek at, you know, kind of how much I'm going to be taking out of them transfers. Make sure my block was all the way down. It's quite a bit. It's like 50 thousandths or more. And just to get to where I want to be with them. I've dropped this cylinder considerably, but it's a lot that I need to drop the transfers, or raise the transfers, I mean. And I would say that if I didn't do the transfer work on this, what would my transfer, I didn't check, but what would my transfer duration be? Well, not much over 100 in duration. So, I think that would be, you know, for guys that do cylinder work and they don't have the tools to do transfer work, this is something that you wouldn't be able to cheat a little bit on the edge to get a little more transfer timing on. You know, like trying to do it with like something like a cutoff wheel or something, where you don't have a right angle tool. You'd be pretty hard pressed to make this transfer work anywhere as near efficiently cheating this one, because you have to take so much out of there to get where we need to go. It comes down to really having the right tools, especially with these, and when you have to take that much out to get something right. Takes a lot of back wall blending too. Get a nice curve in the back wall. You know, a lot of metal got to come out of there. assume a lot of you are already thinking that, man alive, that guy's really raising those transfers a long ways from stock, a long, long ways. But the reality is that this is considered a pretty low transfer duration that I'm putting in here. And I'm talking duration though. I always talk in duration. So I'm doing 117 in duration. It's about 121 and a half, I think, from the top down. And so that's still a relatively low duration number. But it takes that much metal to get it out of there because of where everything was stock before I cut the base, ditched the gasket, all that kind of stuff. So my whole thing that I'm trying to do on this saw is get that exhaust duration down. Bring that exhaust down. Get away from race saw numbers to work saw numbers. Give this thing some more torque and make it pull better and not lose any RPM in the process. And that's what I'm working on here. So it's not like I raised my transfers to like 130, 140, you know, way up high. You know, with 170, 180 degrees of exhaust duration, all that kind of stuff. That's not what I'm doing at all. I'm not even close to that. So 117 on my duration and clean up the back wall. It just takes that much material that I have to take out of that to get that duration up to that point. I said it probably only was 100 or less if I were to have measured it and deciphered just what it was, but I didn't care because I knew I had to raise it. That's all that mattered to me. All right, I like that. I don't do anything with the lowers on these. I've never found it to be an advantage to do anything with the lowers. It's got a large hole in it, feeds very well, and I've never had to do the lowers on any of these. Um, I don't. I know a lot of guys like to get rid of this little ridge on the bottom and that kind of stuff. You know, it probably won't hurt to do that on one of these 660 thick base cylinders, but any thin base cylinder, you're removing a little bit of strength from the base, and if you don't get a gain on it, why make it weaker? It's been my philosophy. So it also increases case volume, crankcase volume. The more you take out of there, the more case volume you're going to have. So if you don't want to increase it, then don't increase it. There's no reason to do a bunch of work right here. So I leave that area alone on these especially, and but we'll continue on. I'm gonna just kind of get an idea where my intake port is, and see what my number is right now. It's going to be very low. I'm going to have to increase that, lower the floor more than where I have it right now, and but I have to have some kind of number to start on. I got the epoxy kind of roughed in down there, and see where I'm at and about what I got to do. So that's the next step in this, and we'll get going on that. Intake port's at 146 where I have the epoxy at. I'm looking for 165, so I can take quite a bit out of there. About 160. See that port match that? I don't want to take anything off that edge. And I'm going to have to, feather everything in there, try to make the port straight. So, I've left some material in there, and I'm going to have to work that all out now for long here. I'm getting really close on my duration, about 164. I might have it now. Got to keep that flat. I want the port to open all at once, so I'm making the floor of the port flat, flat to the piston, so it opens all at the same time. And I'm into the corners. The original port had a big sweep in it, and I'm into the corners back into the aluminum, and in the center there I probably got 50 thousandths of epoxy in there. I'm trying not to widen out the port, but I need to kind of make my corners kind of square. Well, as square as a 1/4 inch bit will make them. And my side of my port's going to be, straight up and down, not rounded. That's I'm looking at all of that all at the same time as I'm working here. It's hard to grind into metal and then feather it off to epoxy because of the hardness of the aluminum to the softness of the epoxy. So it's hard not to make little dips and stuff in there, and so that's why I'm working back and forth, trying to keep my port flat. It's kind of difficult when you're working with epoxy. Another thing is, if somebody times my motors, they'll probably say, hey, that port's more than 165. I check all my durations prior to chamfering, and chamfering does change the duration slightly. So if you see something like that, it's because I've chamfered it after I've set it. And I'm setting it to what I think it should be, 165. And when I get done chamfering, it might appear to have gained a degree or two, and that's fine. Be consistent in how you do it. I found that it makes the most sense to grind my ports to a number that I like to use before I chamfer it, because otherwise I'd have to chamfer this, grind it, chamfer it, check it, grind it, chamfer it, check it. I'm taking out that constant chamfering state, and I only do it once at the end. You can adjust your numbers that way a little bit, however you want to do this, but that's how I do it, and it works out well for me. working on making that port flat. Right now I've got more material in between the window and flange, so it's kind of hourglass shaped, and I'm working on making that all straight. And I'll be running into some aluminum here and there. The whole thing is completely covered with epoxy at this point, but on the floor there's a high spot in the middle. I'm hitting that aluminum there now, and just trying to make it flat, take the hourglass shape out of it. So I've done the lower floor and up the sides a little bit on each side. I still have to do the port window roof, get my sweep corrected, and then I can finish out the roof and the side of the ports. So we're gonna concentrate on the roof at this time, on the sweep. Sweep is from the time the port starts to open on the floor to when the skirt just goes past the roof to where the port's fully open. Okay? That's what I'm calling sweep. And basic general rule of thumb here is around 45 degrees. That varies from saw to saw, but it makes a difference. So I've got I probably have I don't know, 40, 50 thousandths of epoxy in the floor and over 100 thousandths in the roof. That's how much smaller that I've made this port. Where did I come up with this idea? 064s ran a lot stronger than the 660s did. And if I go back and I look at an 064 cylinder, it had less sweep. It had a shorter port window, right? You don't have to even look at the timing. Just look at the port and you can see it was shorter. Slightly wider, shorter. Really not any wider because that was a narrower skirted piston, but in the shape of the port, it would be shorter. You look at the size of the carburetor, what the carburetor can pass, what the boot can pass, and you look at that diameter, measure that, calculate it for area of that circle of that carburetor, and then you just take the width and height of this port window, forget about the round corners, just do a height and width and do the area on that. You'll find that the window is by far larger than what the carburetor can feed. And there's no sense to that. It's making that port lazy, that fuel charge, that air is slowing down as it's getting into a bigger window, right? Starts off a small hole, gets bigger, like blowing backwards through a funnel, and it just gets lazier as it comes out, okay? So what we want is to keep the velocity up and slam it in there. So that's why I make it smaller, and it works. If it didn't work, I certainly wouldn't go through this effort. So, and I make it flat with the skirt on the roof and the floor, the sides straight up and down, and just a 1/4 inch radius in each corner. That's what I want in an intake port. Works well for me. A lot of guys think that port needs to be as big as you can get it, and that's a mistake. Smaller is better in a lot of cases. So I got it set where I want it. Now I have to finish feathering everything in, get these lines straight, you know, get a straight line from the window to the flange, get that flat, go around the whole thing and get that all correct, and I'll be done with the intake port. trying to show you here. Whatever you guys can get from that. It's hard to show. I'm on some metal, bare metal in there. That should shine a little bit, and the epoxy. And I would say that 85 to 90% of that port's covered with epoxy. Get everything the way I want it. A few high spots, whatever that comes through to bare metal, and but that's kind of what it takes. We want to keep the velocity up. You don't want to put a big bell in there. We want to take that big bell out. So that's what it's all about there. Basically, the cylinder work is done, other than chamfering and the exhaust port, or muffler, I should say. And does it for chamfering. You moving on to the muffler from here. On to the muffler. Get that baffle out of there. There's some spot welds in the back I can drill out. And then there's two little like L brackets on the side. And I cut those off, get the block of it out of there. Sometimes I can leave them little strips in there, and sometimes they're not welded in so well, and I take them out. Just depends on what they look like when I get to that point. That's the first step, get that thing out of the way. Gotta find the spot welds. The used mufflers carboned up, I can't see them. I take a little flat screwdriver and kind of rub around a little bit until they show up so I can see where they are. Some have 2, some have 4, 6, 8, whatever they put in there. You know, every muffler's a little different. And it seems that it makes a difference as to, you know, the era that they were made as well. Little 1/8" tip, double cut. I use to grind a center point so I can drill them out. I use the same bit to cut that side out. Not difficult, just need the right tools. As far as drilling it out, you need a drill bit that's bigger than the spot weld. But you should regrind the drill bit flatter so it's not so pointed. So you're cutting more, you know, you don't want to drill a deep hole, you want to drill a shallow hole just through that one piece of metal. You don't want to drill all the way through the muffler. You're just trying to drill off the metal on the top. So change the drill bit angle, grind it a little bit more flat so it's not so pointed, and you won't drill through the muffler. You're only trying to drill through this first layer of metal. You don't have to drill completely through it. If you get, say, 80, 90%, 90% of that metal drilled out, you can just put a punch in here, hit it with a hammer, and drive it out of there. you can break part of that metal or weld to get that out of there. Just depends on how you sharpen that bit. Flatter you get it, the better it is for doing this, but the harder it is for it to center. So it wants to wander a little bit. Flatter they are, the more it wants to wander. Center point helps that a lot, and you know, takes a little pressure to make the bit work. But that's better than drilling through the muffler. I got one side drilled all the way off, the other side almost. There we go. Little pieces on the side now definitely look like they want to come out of there. Double bit, double cut bit. Most of the time I grind it all the way, but spot welds are right on the edge, so I just kind of got the spot welds off, get the whole piece out of there. I'd rather take the time to take these out now than to have them fall out and end up in the cylinder. It's all just part of the process. Not very flat. I sand on it. It's hitting out here, you know, not in the center. Doesn't really matter, but I have to go look, see if there's a heat shield for this thing. Some saws have them, some saws don't. To be honest with you, I can't remember. I don't think so. Not one in the box. This is an aftermarket cover. It's got that silly little hole thing in it, right? I don't like these. There's no screen in there. There's no nothing. And so I don't recommend these. What I got is a brand new dual port muffler cover for it. They're kind of pricey, but I think they're worth it. I also like the dual part just because it has this extra reinforcement on the front of it. They do what they need to do. I'm not a big fan putting a port on the front, but these work quite well. So that's what we're putting on for cover. Now keep in mind that, you know, everything has a little bit of give in it, right? And I've lowered that cylinder, you know, around 50,000, 60,000. And when I do this, you know, port match on the muffler, I slide the muffler up on the cylinder as far as it wants to go. Better off to work with it than against it. always mark my gaskets. I put it back on the same way, so I'm not trying to figure out where it was. Just mark the thing, goes right back on. It's a dull knife, right? I use it as a deburring tool. Works good on aluminum. Sometimes I'll use my diamond stone on this. It's metal. But there really isn't much of a burr on there, because I was pinched between two pieces of metal. So the burr is not very much. It's just a whisper, you know. So it ain't too hard to take it off with like a deburring tool. We have to deburr that as well. We're going to enlarge the stock port. I like to try to keep it behind the deflector. And you can see on these, the deflector is very small. But I like to try to keep it behind the deflector. And if I wanted to make that a lot bigger, I would add something onto this deflector. I'd weld another piece on here, especially for a full wrap saw. Otherwise it blows right on your hand if you're hanging on that side. So if I like to keep it under the deflector if I can. If not, sometimes I'll add some onto it and improve on that. But I'm going to put the dual port cover on it. I'm increasing the stock port, and I'm adding another port on the side. This muffler has this little extra brace in it, and that hole comes out kind of on the edge of that brace. And I cut, part of that brace away to make room for whatever you want to put in there, nut, whatever. I'm doing a rivet nut, but I still need room for that expansion there, and so I want to trim that away. Also want to clean the carbon up out of that. Same thing on this hole. It's right next to that little brace. Get rid of a little piece to the corner of it. chasing my tools around today, ain't I? Back into that little brace. Head out of there. I don't want to take it out. It's in there to help support the cover, and there's really no reason to take it out. It's welded in there good enough. I didn't cut anything where there was a spot weld, so you know, it's not like I'm making it weaker. I had a few questions about, do I do stages of porting? You know, like just a muffler mod or a gasket delete or, you know, different stages of porting. And my answer is no. Um, it doesn't make any sense to me to do so. Um, you know, first off, I got to come up with some different pricing, you know, of what all you want done and how far you want to go. And truly, the price ain't going to be much difference. A lot of the labor is not so much in the porting. It's part of that labor is just taking the saw apart. Part of that cost is shipping. Um, you know, I include shipping, return shipping with my porting, and that's all part of that price. So if you send me a saw and you only want me to do half of my work, I can't charge you half as much money because, you know, the shipping doesn't change because of that. The time that takes me to tear it apart, put it back together doesn't change. And so I might save 15 or 20 minutes by not doing something else, or maybe even a half an hour. But that's might all the difference be, right? So now you're going to pay to ship the saw to me, do half the work. I pay me within $50 or something of full price. I'm going to ship the thing back. You're not going to be happy with it. You're going to ship it back to me again and have me finish it. Am I supposed to finish it for $50? You know, all the labor is right back into it. The shipping is back. Everything is back. Take it all back apart again. It doesn't make any sense to me. So I don't offer it. Would I do something different with a race saw? Absolutely. But you're going to pay me maybe 3 times as much money to build a race saw. Maybe even more than that, because of the time it takes, the part swapping, the parts. You know, if I'm going to go all out, if we're going to stroke it, you know, the last I knew it was $800 stroke a crankshaft. If you're going to bore it, have it replated, you have the plating costs. You have all of that. That's $300 or whatever it is dollars. An oversized custom-made piston. There's only a few guys out there that have the rights to those pistons. I have to go to him, try to get a piston. And we're swapping a lot of other parts. Ignition systems, carburetors, intake boots. Maybe we put a whole big fiber block on it where we glue an epoxy block or a fiberglass block right onto the cylinder and machine it and mill it from there. Same with the exhaust side. Weld the block right on the exhaust so you can do more with the exhaust. And then cut the head off, make a whole new head, right? It ain't uncommon to stick $3,000 or $4,000 into an all-out, full-blown 3140 race saw. So, you know, if you want me to do that, I can. I've never gotten that far in depth in them, but I do have contacts. I do know the people that I need to know to make that happen, and I can do that. Don't expect it back next week. You know, I don't know how long it would take to get a crank back. Pull the saw apart, pull the crank out of it, send it to a guy, change the rod, change everything, stroke the crank, put it all back together, send it back to me. I have no idea how long that takes. Take a cylinder, cut the head off, send it in, have it bored, have it plated, send it back. I have no idea what that timeline is. So if you're interested in something of that nature, it's not like I don't have the ability to do it. I don't like to do it. It takes way too much of my time, but it's possible, you know. But it takes some money. Personally, I wouldn't get that deep into racing. Kind of takes the fun out of it. Um, Lots of money, got to go to a lot of shows, you got to be real dedicated in doing it. Practice a lot, get good at it. You know, I'd rather just do some fun racing and be done with it, and not get that serious into racing. Tune pipe too, got to put a tune pipe on it. It just goes on and on and on. You know, I mean, you can spend $400 or $500 just for a tune pipe. When it comes right down to it on saws like that, my labor is the cheapest part of that build. You know, what I'm putting into it for my time and my labor is cheaper than almost any other component in that saw that needs to be worked on. We get done stroking the crank, we got to put the crankcase in the lathe or mill, and we got to increase the case volume to make room for that crank to go around in there. All that work has to get done. There's a lot of work involved in building a 3140 full-blown all-out race saw. You know? And you need a sprocket, big sprocket, and the bar that works with that big sprocket, belly bar, whatever you got to do, and a race chain, a really good race chain. You know, some guys get $300-400 for a chain. So, like I said, for me, man, I would rather just hop up a 661, get everything I can out of it, and go around and race some small races and have some fun. You know, meet people and have fun and enjoy the day. Win, lose, or draw, who cares? It don't matter anyway. You know, that's my point of view on it. Small local races are fun, fairs, whatever, you know, that kind of stuff is fun. But getting full, blow it all out into it, it takes a lot of fun out of it. The competitiveness is really there, you know, and I would just rather have fun. I enjoy doing this for fun, and you know, I enjoy working with loggers to improve their needs, and you know, I like small little races, local. You don't have to go far. Put one on yourself, you know, have some fun. Invite a bunch of guys and just have fun. Muffler's done. Um, we're going to be putting some more stuff together here pretty soon.